All right. Today we're going to start Unit 4. We're going to learn about the binomial probability distribution and some related topics. So today we're going to describe distributions of random variables and use those descriptions to find the probability of events. Okay, so there's a general category of random variables. Uh, a subclass of that are the binomial variables, which we're going to look at after we look at the general random variables today. Okay, a random variable is a quantitative variable that assumes a value determined by chance or random outcome. Now, you're used to algebraic variables where there is a certain set of there's a certain answer or maybe a couple of certain answers. Um, and it is what it is. I mean, you solve the equation, you've proven that that's the answer. With a random variable, there is no proving that any answer is the answer. There are at least two, usually multiple answers that are going to just be determined by chance. So there's two types. The discrete random variable. A discrete random variable is a quantitative random variable that can take on only a finite number of values or a countable number of values. So, for example, the number of books in the college library, okay, there that can be counted, and it is one particular value. Oops. A continuous random variable is a continuous random variable that's quantitative that can take on any of the countless number of values in a line interval. So the amount of rainfall in your state during the month of June would be a continuous random variable. Now, one rule of thumb that you can use, it's not always going to be the answer. If you can count it, it's a discrete random variable. If you're measuring, it is a continuous random variable. A probability distribution is an assignment of the probabilities to specific values of the random variable or to a range of values of the random variable, depending on whether you have discrete or continuous random variables. We are going to focus in today on the probability distribution of discrete random variables. Okay, so you have to have all the values of the random variable listed, their corresponding probabilities listed, and the sum of those probabilities have to be 1. If the sum is anything other than 1, then the probability distribution is not valid. Okay, so here would be the probability distribution of the rolling of an ordinary 6-sided die. The values that we can get upon the roll are 1, 2, 3, 4, 5, 6. Each one of those occur 1/6 of the time. If you add all of those up, you're going to get 1. You can have a frequency distribution. So here we have a frequency distribution, and then we can convert it to a probability distribution. So here we've got a boredom tolerance test, and the scores for 20,000 subjects, and people can score between 0 and 6. You see here they've got the number of subjects. Well, you can figure out the probability by taking the number of the subjects and dividing by 20,000, and that's going to give you the probability. So you calculate the probability of each one of those, and it comes out to be 1. A probability histogram is just like a regular histogram. You have your values in the center of each class or bin, and then they use the probability here, and your bars have the height of the corresponding probability. We can find the mean and standard deviation of a discrete probability value, a discrete probability distribution. These are going to take a little bit of time and effort, and you're going to have to be really organized. So you really want to pay attention and watch how I organize my work. The mean mu is an expectation or expected value. You'll often hear find the expected value, and that means just find the mean. It is the long run average. And our formula for it is the sum of x times p of x. So you're going to take each value of x and multiply it by its corresponding probability and then add all of those up. The standard deviation uses the mean. We're going to have the square root of the sum of the difference between each observation and the mean. And we're going to square that, and then we're going to multiply by the probability of x. All right, so if we want to find the mean of a probability distribution where outcomes are from 0 to 4, and here we have our corresponding probabilities, we just do 0 times 0.3 is 0, 1 times 0.3 is 0.3, and so on. And then we add those up to get 1.4. Sometimes people go, well, don't we need to divide by something? We already did the appropriate division when we came up with the probabilities. These are going to weigh each of these outcomes appropriately. So you just multiply the outcome times its likelihood, and then you add all that up and you're done. So the mean in this case is 1.4. We have to know the mean to find the standard deviation. All right. So to find the standard deviation, first thing you want to do is you want to find the difference between the observation and the mean 1.4. So I'm going to do 0 minus 1.4 is negative 1.4. 1 minus 1.4 is negative 0.4. 2 minus 1.4 is 0.6, and so on. And then we need to square those. Guys, when you're squaring these, make sure you square the negative away. The whole point is to get everything positive. And so we negative 1.4 times negative 1.4 is 1.96, and then so on. Now, again, we need to weigh each of these by its likelihood of occurring. So I'm going to do 0.3 times 1.96 and get 0.588. You're going to do 0.3 times 0.16 to get 0.048, and so on. And when you add these up, you get 1.64. 1.64 is the variance. And so to get the standard deviation, you have to take the square root. So you add up all those values and then take the square root. All right, guys. So you've got problems to try on your own here. You're going to identify the random variable. Hint, the random variable is never going to start off with probability. So it's always going to be one of these labels, and it's not going to start with probability. Is the random variable discrete or continuous? If you can put it in a table like this, it has to be discrete. What is the mean of the random variable? Well, you had the formula for that earlier. You just need to apply it. And what is the standard deviation of the random variable? Same thing. Grab that formula and apply it to this case, and we will go over this first thing in class. Thank you for watching the video. Please contact me if you need any help. I hope you have a great day.